Hi, this is Meena here welcoming you to my channel Grow Joyfully. In this series, I'm explaining the joyful journey that I undertake regularly at home by doing aerobic composting in big terracotta pots. I'd shared two videos earlier, how I fill a large terracotta pot at one shot and how I give the mix a thorough stir 6 days later. I hope you watched these two videos. In this third video that you're watching today, I'm sharing with you the miracle that I witnessed as I opened the bin on 28th February 2021. Namaste, this is Meena here. We started a bin on February 8th, 2021, and 6 days later I showed you the bin and I also demonstrated how to give a very thorough stirring of the entire mix. Today is 28th February 2021. In between, I have not added any greens or browns, but I have been giving the mix a full stirring every 3 days. Let's now take a look at the bin now that 20 days have passed by. When I look at it, I realize that the bin contents have fallen below 50%. And in order to show what is inside, what I'm going to do is I'm going to transfer the contents to a tub so that you can see it fully. I have transferred the contents to a tub only to demonstrate to you in detail how the mix looks. In real life, you do not have to do this. All you have to do is only regular stirring from top to bottom and side to sides in the same bin in which you did the starting, you did the layering. Okay, now 20 days have passed by, and if you recall, I put one full bin, one full tub like this, full of greens. Lot of veggie peels were there, green peels were there. Let me see how much I can find. And if you look at it, what is very, very fascinating to note is that I am ransacking the entire mix to see if I can spot any greens. Do you see any greens? You can zoom here. Absolutely all of them have gone, disappeared. This vanishing trick is indeed magic. In fact, if this is Mother Nature's magic, this is much better than human magic. I can't find even a single piece. I'm trying to, and it's pretty cool. It's not hot. So, you see here, I'm showing completely. If there are some plastic stuff like this, it's time to remove. They will never get composted. You can see here, I see only brown matter. This is a wonderful sign that we have started off very well. There is a huge magic, there is a huge alchemy that has happened when browns met the greens, and bacteria did the work, and they have gobbled up, they have decomposed all the greens now. Not a single piece of greens is remaining. It is not rocket science, this composting, but it's a very, very fascinating science where physics, chemistry and biology, all three come together. How do we understand that? I'm not going to take a session on science here, but I'm going to look at, there are a few things that we did when we filled this bin, and why did we do it? And in the process, we'll understand the science. If you recall, we added one bunch of starter. That is nothing but the compost from the previous batch. And then we layered the browns and the greens in the ratio 3:1. And I said terracotta bin is the best, which has got holes for moisture management. Let's look at only these 3 points. If you ask me, did we do the composting? Did I do the composting? No, I cannot convert a banana peel, and I cannot make it vanish. Even if I'm the best magician on earth, I can't do that. But I brought a handful of aerobic bacteria into the bin, and they only kick-started the decomposition process. They are small in number, so we started putting a lot of greens and browns. Why did we put greens and browns? Because in one handful of bacteria cannot do the decomposition for the entire bin here, the contents of the entire bin here. So they needed food. Bacteria need food for two reasons. One, they need to multiply. Their number was not sufficient enough, so they need to grow and multiply, and they need energy in order to do the decomposition work. Where do they get food in order to grow and multiply? That comes from nitrogen, and nitrogen is predominantly present in the greens that we added, the vegetable peels, the fruit peels, etc. And the very fact that the greens are gone means that bacteria have happily multiplied, and they have grown, and they've gobbled up all the greens, and they got their nitrogen requirement. It's not enough if they grow and multiply. They also require energy to do the work of breaking down complex substances into smaller ones. And for energy, they rely on carbon. And carbon is predominantly found in the browns. That's all we need to learn, understand commonsensically. So why did we put greens and browns? Greens contain nitrogen, and they helped in the bacteria exploding, multiplying in their population and growing. And for them to do the decomposition work, they need energy. We provided energy by adding browns, which contain predominantly carbon. So the science is very simple. Greens are stuff which come from the kitchen. The vegetable peels, food peels that we added, they are rich in nitrogen. We added a lot of brown material, predominantly in the form of dry leaves. The brown matter contains carbon, and that provides energy for the aerobic bacteria to do the work. You would have noticed me emphasizing the ratio 1G, 3B many times. 1 part of greens, 3 part of browns. What is so sacrosanct about this ratio? Why can't we put 1:1 or 1:2? That's a question I would like to address now. Now, greens were 1 and browns were 3 parts. Suppose we put only greens in a container. What will happen? You put only greens in a container in your kitchen, you will see them rotting. Decomposition will not happen, rotting will happen. Similarly, if you take dry leaves, pile them up in a bag and keep them aside. Don't add any water at all. Nothing will happen. The dry leaves will remain as dry leaves. Probably it will take a few years for them to decompose. Decomposition will happen, but it will be a very slow process. Not like this. So, both of them need to be added, and in the proportion you will find carbon is more than the nitrogen. Simply because nitrogen is used only for growth and multiplication, carbon is used for two purposes. One is to provide energy, which I told you already, for them to do the decomposition work. Second and more technical point is that when the bacteria grow, most of their cell is made up of carbon. So carbon is also used for their bodybuilding, so to say. So carbon is always required more than the nitrogen. And here, scientifically people say carbon-nitrogen ratio should be in the form of 1:25 or 1:30 carbon-nitrogen ratio. But how do we calculate carbon-nitrogen ratio in practical terms when we bring fruit peels, when we bring dry leaves, shredded cardboard, cardboard shreddings, etc. From a layman's point of view, how do I convert that carbon-nitrogen ratio? How do I implement it here? This is where that 1G 3B formula comes in. So when you add 1 part of greens and 3 parts of browns, automatically you are adhering to that carbon-nitrogen ratio. I don't think I calculated scientifically the carbon-nitrogen ratio of the fruit peels, the leaves, etc. I intuitively followed the 1:3, and the proof of the pudding is in the eating. You can see that the nitrogen is, the green matter is gone, and even the brown matter is disintegrating. You can see that I had put full leaves. I had not crushed the leaves at all when I layered them. but you can see that they are slowly breaking down. In fact, had I cut them into smaller pieces in the beginning itself, I didn't have time, I told you. So if I had put, I would have seen a higher decomposition even of the brown matter. In my next video, I'll explain about the importance of maintaining the appropriate moisture level and aeration within our aerobic composting bin. Thank you for watching my video. Have a great day.